Yes. Yes, absolutely.
You were looking for, so it's not anything in particular, you're looking for the strength of the correlation, positive correlation, and negative correlation, maybe it's a strong correlation.
Got them correct.
No, it's not long. You're not calculating anything, you're just looking at, does the sort of strong correlation or positive.
Yeah, no,
Okay, for 2.1, did we leave off with, for whatever reason, this has stopped. Or did my Teams crash? That'll be why. Did we leave off with the population versus sample? Is that where we ended? Did we talk about that fully, or did we like get it in right at the end? And so, like, for instance, did we talk about the idea that like a descriptive statistic of a particular population could be an inferential statistic if that population is used as a sample? So for instance, we like look at the number of sweatshirts in this class. Then in terms of how that statistic works for this class, it is descriptive. But then if I wanted to expand that to like the broader population of the school, that descriptive statistic then turns into an inferential statistic. That's kind of the thing I wanted to highlight there. Most of what we're going to see, and I kind of mentioned this yesterday in Unit 2, is going to, especially kind of at the beginning here, be a lot of vocab. So we're going to, again, kind of continue to expand upon some of these ideas. Before we take a look at a couple of our new terms, I want to take a look at an example that kind of incorporates a couple of the ideas that we have looked at so far. So in this case, we're looking at Mr. Spencer's math class. In particular, we are interested in what is going on with students who are regularly attending class and what happens kind of as that attendance declines. As far as thinking about the variables that we are studying here, or that we are interested in, what are the two variables that we are looking at for this particular survey? Yeah, so time spent in class, which is presented as what kind of metric? So like percentage, we could think of it as like number of absences. The way they describe it is like percentage of attendance, but like number of absences would certainly work as well. But just like how it's presented here, it's given in terms of like some kind of percentage. And the other one, as Sophie said, is the grade. And in particular, how is this grade presented? It's going to feel like this is a little bit of a weird specification to make. It's going to make a little bit more sense why I'm doing this a little bit later. Are we doing like absences or percentage attendance versus like whether they got like a 97? Are we letter grade? Okay, so specifically we are looking at this, what I might describe as like categorical letter grade. Now, it feels a little bit weird to make this distinction because again, like in our heads, having an A tells us a numerical value that we have to live between. Like if we're getting the letter grade of an A, then our numerical value probably sits somewhere between a 90 and a 100. If we're getting a B, then we're sitting between an 80 and an 89, or depending on whatever the grading scale is. But there is some kind of numerical overlay that we could put to these letter grades. But as far as these variables are defined, they are defined in this slightly more categorical, slightly less numeric way. And so I'm capturing it. So it's like slightly numeric, and certainly we could impose some kind of numericness to it. We certainly could express preference of getting like a B over a C, things like that. So it's not like these are perfectly interchangeable buckets that don't have any kind of value over the other, but they are presented as letters rather than as numbers. Okay, as far as thinking about where these kind of variables are coming from, what is the actual data that is being studied? Like, what would be a point of data for this particular observation? Where are we getting this information from? Okay, so the class as a whole would be like maybe the whole data set, and then an individual like point of data would be a student. The students are going to be the actual like things that we are kind of looking at here. Very good. Okay. Here's where we get into a little bit of the like messiness of gray area. The thing that I want to just say very explicitly here, if we are referring to only what is being described here, not superimposing what we would do with this information, not jumping to any conclusions that we might be tempted to jump to with this information, is what we are presented with descriptive of a particular population, or is it being used to either generalize or make predictions about something beyond what is being studied here? Are we using that as it is written for this particular problem? So do we mention, say, trying to guess a student's grade based on their attendance, or what we think the school's trend would look like based on this particular classroom? Yeah, so notice that as it stands right here, we're not using this information quite for that. Could we use this information to try and do that? Absolutely. And in fact, that probably would be the next step, right? Is saying, hey, I've collected this data. Sure, we can talk internally about what this data has shown, but the actual utilitarian value, kind of exactly as Maya was suggesting, would be to use this to generalize or to use this to make predictions. It's not being done here yet. We are not really making any statements about what's going on beyond Mr. Spencer's classroom. So for the time being, Dylan is absolutely correct. What we see is just descriptive. But like we said yesterday, something that is descriptive can absolutely be used inferentially. Now, if this is purely descriptive, if we're not trying to use this to make any kind of claims about anything, then what is the population that this data is describing? The students where? Is it in the school or is it in the class? In the class, and what would we be saying if it were in the school instead of a population? This classroom would be a sample of the school overall. And that would be the transition of using this as a descriptive statistic of a population versus using this as an inferential statistic that we derive from a sample. So as it stands right now, the population would be Mr. Spencer's class. But could we, again, generalize this to talk about maybe results that we would expect to see from all math classes? Certainly we could try, right? Now, whether that would be correct or not is maybe matter for debate, and we'll talk about like different ways that we can take samples and things that we have to be careful of. That'll be a little bit more what we do tomorrow. But as it stands, as it's described, we're not really concerning ourselves with anything. Our whole world, this whole ecosystem is purely looking at what's going on in Mr. Spencer's class. The way, though, that we would turn the descriptive statistic into inferential is by trying to expand or by trying to extrapolate. If a new student walked into Mr. Spencer's class, how would they perform? Very, very good. From Mr. Spencer's class, have we arrived at this conclusion by taking a sample, or have we looked at the population holistically? Yeah, we've looked at the population holistically, right? We're not saying that we interviewed 10 of the 30 students in Mr. Spencer's class, and this is what we found, and so we are making predictions that this is going to be what's going on here. Notice again the use of sampling to be inferential. Because what we're talking about is purely descriptive, this is the whole population must be our data set, and so there is no sampling that has been conducted. Now again, if we want to broaden our population, then all of a sudden Mr. Spencer's class again becomes a sample and the descriptive statistics become inferential. So again, it's a little bit of weirdness of like, how are we using this? What is the target demographic overall? As it stands, though, we're just simply saying what's happening with Mr. Spencer's math class. Okay, and then just in general here, if we assume the kind of numerical nature of these letter grades to kind of be consistent with our understanding of what they should be, how would we describe this relationship? What's going on as, say, either the grade increases to the percentage attendance, or what's going on to the percentage or to the grade as the percentage attendance increases? So as you attend more classes, or as students in Mr. Spencer's class attend more classes, what tends to happen? They tend to have a higher grade. And so how would we describe that correlation? Positive correlation. Very good. Which I'm going to put a slight asterisk on, mainly because that required us to assume that there was a positive direction in going from an A to a B, which there is, right? We understand that there again is like this numerical framework through which we can interpret the A's, the B's, the C's, the D's. But technically speaking, if I just gave you this and it was entirely unlabeled, we wouldn't necessarily claim that there's a positive relationship in moving from like A to B to C to D. We might just be making like categorical shifts. But certainly when we ascribe it to the numerical value, yeah, going from an 80 to a 90, that is certainly increasing our variable. Okay, so a couple of things that I want to highlight, which is going to be the stuff that I am kind of fixating on as we're going through this example. As we work through something like this, we'll notice that there are a couple of different ways that we're able to describe some of the data. For instance, when we're talking about percentage attendance, that's a very numerical way to describe what is going on. And grade certainly was something that could have been described numerically, right? Like maybe we're talking about like an upper 90 or like a mid 80 or something along those lines. We could certainly try and give a more serviceable breakdown. But the way that it was presented in this particular case, is rather than as a set of numerical values, as a set of essentially buckets that we are kind of sorting into, right? So yes, to our understanding, there is numerical value in getting an A. We know what that means as a number, but as it's presented here, we don't really see that. And there are certainly variables that we could look at where having that kind of superimposition of does this work as a strong a numerical value certainly does not make sense. I think a really clean example of this that I came up with for fourth period was to think about, let's say, Tetris blocks. And let's consider maybe 3 different variables that we might use to describe Tetris blocks. We could talk about their color. Sure. We could talk about the number of little blocks that make up a single Tetris block. And we could talk about how good a particular block is to show up in a particular game, right? So maybe that like yellow, long, skinny block is better than the 2x2 square block in some way. We have, through this, several different measurements that we are able to kind of discuss. the first and foremost, number of blocks is something that we can just give a very simple, easy numerical value to. But color and how good the block is, how strong of a block it actually is, are a little bit less numeric and lend themselves a little bit more to being categorical. We would classify in terms of categories. This is a yellow block, this is a blue block, this is red, green, whatever. And while we might be able to rank, say, how good these particular blocks are, and we might be able to ascribe numerical values to it, overlay those kind of numerical values onto the variable, it's not implicit within the variable itself that we should be doing that. So a couple of different types of variables that we are seeing here. The biggest distinction between variables that we are going to be looking at are the idea of qualitative variables versus quantitative variables. And at its core, qualitative variables are going to be categorical, and quantitative variables are going to be numerical. Easy way to remember this, quantity is just a fancy word for number. So quantitative relies on numbers. Therefore, whenever we see a quantitative variable, it's going to have numbers attached to it. Within this breakdown, we can further break down actually more both of these types of variables. We're going to start with the quantitative though. Within quantitative variables, there are two subsets or subdivisions. And a really kind of good way to highlight this, again, nice example here, would be if we were to consider, say, the average height of students within this particular class and the total number of people wearing sweatshirts in this class, coming back to that sweatshirt example. All right. There is something fundamentally different about the values that we would expect for those two variables. Can anyone kind of think about, can anyone guess as to what the fundamental difference would be in the values that we would expect to see for height versus the number of sweatshirts? Yeah, Elena. Okay, so what do you mean by continuous? Can you expand on that idea? Okay, so something about maybe maybe like a constant thing. So maybe one of those variables is going to change day to day, and one of those variables is going to pretty much be the same if we measure it a single time. That's a good point. And so maybe we would get like different samples if we looked at number of sweatshirts, or we'd get like similar samples if we looked at the heights. I think that's a really interesting difference. I think that's a good idea. Anything about the numbers in particular that we would expect for those two measurements? Why? Okay. Okay, so what would be like a number that we would not expect to get for number of sweatshirts or number of sweatpants? Well, we could get 3, but what couldn't we get? Yeah, no, I definitely agree. How can we classify that in terms of types of numbers? Any of my pre-cal students want to help out? That day 1 pre-cal, and we did that big, giant sets within sets within sets. What kind of numbers would we expect to see for heights versus what kind of numbers would we expect to see for number of sweatshirts? If you hint sweatshirts, you could start it with an N or a W, although the pre-cal word that we looked at was N. Yeah, natural numbers. What does it mean for a number to be a natural number? It's a whole number. It doesn't have a fraction, right? We wouldn't expect to see 3.5 sweatshirts, right? To Dylan's point, either you have a sweatshirt or you don't have a sweatshirt. You're not going to count the number of sweatshirts and see that there are pi sweatshirts in this particular classroom on this particular day. You're not going to get 7.9. You're not going to get anything other than a whole number. Also not a negative number, although heights also don't necessarily need to be negative. So it's not necessarily that these values are all inclusive. But if we were to take the average height, would we be particularly surprised to see that the average height was 5 foot 4.666673291? Would that be particularly crazy, particularly wild for a measurement of heights? Absolutely not. We would be comfortable with that because heights kind of come on a continuum. There isn't a clear jump from there's this height and then there's this height and then there's this height and there's no one in between. You can't have any fractionals. You can't have any kind of piece of the whole. Rather, we would see, or we would expect to see maybe at least approximating some kind of continuum for our height. So this is the difference between discrete and our continuous variables. Discrete variables are going to be those variables that have space between them. This is like our sweatshirts, right? So we have a definitive number. This is like a count almost of, say, number of people who are wearing sweatshirts. Important to note, this is often going to be done with like whole numbers, with natural numbers. It doesn't need to be. For instance, we could count by halves, and that would still be discrete because we would never expect to get like 0.75. Or we could count by tenths, and that would be discrete because we would never expect to get 0.001. Or we could count by hundredths, and again, it would be discrete because there's a little bit of space in between. It's like walking up steps rather than kind of climbing a hill. So as far as kind of our definition goes, we could think of it, yes, as kind of like counting. I kind of prefer to think of these as like the values that our variable can take have well-defined space between them. Defined spacing. And good examples would be like number of sweatshirts or other things that we can count. Most often you're going to see this as like a count. So for instance, for our Tetris example, we would probably not expect, but the number of blocks would be a discrete variable. You're going to get a whole number of blocks for a particular thing. Whereas continuous variables, these variables can be any value within a specified range, right? If I tell you that the smallest height is 4'11" and the tallest height is 6'5", and I'm asking you to, and I give you a student's height, you actually probably wouldn't find many people who are like 5'5" on the dot, or you wouldn't find many people who are 5'8" on the dot. There's a little bit of variance there. There's a little bit of error. There's going to be some fractional values involved, and there's no reason why someone couldn't be any particular height within that given interval. Now, our measurement system, again, creates discreteness from that, right? Like the difference between 5'1" and 5'2" is a discrete difference. But if you actually were to measure someone's height who was 5'1" or 5'2", then realistically, they'd probably fall somewhere in between the two. right? You're not forced to land on 5'1". You're not forced to land on 5'2". There's no reason why you couldn't be somewhere in between. All right. It's a little tricky. We'll get the hang of it. This is like a like the whole idea of like what is continuous is such a mathematical headache. And we're not going to really unpackage it even a little bit. Take calculus in college and let me know how that goes. Take real analysis in grad school and let me know how that goes. But at the very least, our intuitive understanding of kind of like what it means to be continuous is pretty serviceable. It's going to take us pretty far. So let's take a look at that example that we were looking at before, where we have, say, the grades and the percent attendance. All right. What do we have here in terms of our variables? Which of these is going to be quantitative? Which is going to be qualitative? Kind of as it's presented here. Which of this is categories? Which of this is numbers? Yeah, letter grades are going to be our categories. I would definitely say that the grades specifically, actually, I like that you specified that it's the letter grades, would be our qualitative. And therefore, what would the quantitative be? You're not always going to have one or the other, but in this case, what would the quantitative be? The attendance percentage. Definitely is going to be quantitative. Now, could our qualitative variable be presented in a quantitative way? Sure, why not? Right? Absolutely, it could be. Instead of saying A's, if I say that we're sitting between 90s and 99s, all of a sudden my qualitative variable is quantitative, right? Now there's actually a numerical value attached to it. And so certainly we could present the grades in a quantitative way, but as it is listed here, definitely qualitative. Okay. For our quantitative data, which we said is the percent attendance, we need to figure out, is this going to be discrete or is it going to be continuous? Is it possible for us to see every single possible percentage under the sun between 0 and 100, or is there something that's going to limit this? This is a little bit tricky. So it is going to feel continuous. I certainly agree with that. And it's, to some extent, it's like, well, why would there be some percentage that we couldn't take on? And you're not wrong, that there isn't a particular percentage that I can point to and say that it's never going to be this percentage. But let's try taking a look at why I would claim that it's discrete. So I actually don't dislike continuous as an idea. There is no reason why a percentage couldn't be 55.5% or anything like that. The main problem that we're going to run into here is that there are before we pack up, that there are a limited number of days that we can miss. So for instance, if there are, let's say, 37 days total for a particular class, and we miss, say, 25 of them or 24 of them or however many, then there are 37, I guess maybe 38 distinct possible ways that we can have our attendance be for this particular thing. And so while they might not be clean, they'll be messy, they'll be fractional, they're not going to be particularly fun, there are a finite number of different ways that we can attend, which is a little bit tricky. That number changes when my denominator changes. If I had 39 days instead, I would get a different set. It would be now 40 different ways that we can do it. But because we are limited by the number of days that we can miss, this one actually turns out to be interestingly enough, discrete, although I think the logic with the continuous is not that logic.
What's the difference between discrete and continuous again? I'm confused.
So continuous, think is like heights, where like it could be anything between like 4'11" and 6 foot, whatever the maximum is, and we wouldn't be particularly surprised.
Okay.
Discrete is that there are specific values in that range that it's allowed to take, and it couldn't be anything in between.
Okay.
So like think of the discrete as there being like, they're like steps that we have to walk up, and we can't be on like half of this. Yeah.
I didn't get a chance to finish.
Did you have the full time, or was there still time on your test?
It was a little bit of time left still.
Okay, if you want to, if you need to stay and wrap up the last, did you submit already?
Oh, I didn't get a chance to submit. But it had, when I closed my laptop.
Okay, let me see here.
If you able to pause it and let me start again tomorrow.
I can't do that on Schoology, unfortunately. But it hasn't submitted yet. You have about 5 more minutes. If you want to take another 5 minutes to try and knock it out here, unless you have to go like right now.
Yeah.
Okay, go ahead and submit it, and then I can give you 5 minutes at the start of next class to wrap it up. Thank you. Have a good day, Liz.